In this video, I'm gonna continue give you more example on the changing the order of the integral, and we're gonna compute the value of the double integral. The first two example is gonna be we're gonna try to change the order or setting up the order in like two different ways. And another example, which is the last one, will be we're gonna compute the double integral by changing the order. So for example 13, you see that the question just asks you to sketch the region and change the order of the integral. That you see that the final answer that you need will be in terms of you need to change the order from dx dy to dy dx. So the answer would be just the double integral of f xy and dy dx, and the thing that you are looking for turn out to be the red one that you're going to put up here and the yellow one that you're going to put up here. So the answer will be in this form. However, for this one we must first sketch the region. So for here, you would see that you have x lie between two curve, and you have y lie between 0 and 3. So you see 4y over 3 less than x less than square root 25 minus y squared. Okay, and you have y between 0 and 3. So for this one, you're gonna sketch x equal to 4y over 3, and you have x equal to square root 25 minus y squared. And so you gonna just try to sketch this region. So for this one, you gonna just have y equal to 3/4 of an x. And for the second one, you just have x squared plus y squared equal to 25. Okay, so you see that x squared plus y squared equal to 25 will give you circle. Okay, so the radius equal to 5. Okay, 25 is 5 squared. And you gonna have the center at 0, 0. Okay, so this one we gather the information of our graph first. And you also see that you have x is positive because x is the positive square root. Okay, so you have x positive. So it's going to be only on the positive side. Okay, so it's going to be the thing that we can analyze from the equation of the thing that you see. So you have x equal to square root of 25 minus y squared. So you need x only the positive side of the circle. So I would begin drawing this guy by you have x-axis and y-axis, and you have only the positive side of x squared plus y squared equal to 25. So you must have the whole circle like this. Okay, but you need only the positive side, so it's going to be just only on this side. So the circle that I will draw is going to be just this circle. Okay, so it's going to be just only on the positive side. So you have 5, 5, negative 5. Okay, and you have x equal to 3/4, y equal to 3/4 x. So you see that it's going to be x and y. Okay, and you have x equal to 0, y equal to 0, and you're going to put x equal to 4 to gain the non-fraction. So you have y equal to 3. So you see that 4, 3 also satisfy. Okay, so you see that also we have 4 square plus 3 square equal to 25. So it means that 4, 3 is on circle. So this one you have x equal to square root 25 minus y square. Okay, and you have 4, 3 is on circle. So this is my 4, this is my 3, so this is my 4, 3. Okay, and you have another one which is the origin. So it's gonna be this guy. Okay, so this one will be just the line that we looking for. So this one is 4, 3. Okay, so this one is our line y equal to 3/4 x. Okay, so you have y equal to 3/4 x. And you see that this guy will be just, you have this setup. So this one and this one. So it's gonna cover from y equal to, from x equal to 4 y over 3 to x equal to square root 25 minus y square. And you have y will cover from 0 to 3. So you see 0 must be somewhere down here and 3, so that your y before. Okay, so this is 0 to 3 that come from the green one here. Okay, so the region that we are shading turned out to be this region. Okay, so I cannot see anything, sorry. Let's make it darker. Okay, so this one will be the region is okay, so that the region is that you have. So in order to compute the double integral over this region S, you see that if you have y run first, so you need dy dx, you're gonna have y run first. It's gonna be from the x-axis up to the green one. However, it's not gonna be the whole interval. So it's gonna be the x-axis up to the green one until 4. Okay, so you see that your x must be divided into x between 4 to 0 to 4. That is going to be one region, and you're gonna have another one which is you have x between 4 to 5. So you see that x in this area is going to be the bottom to the top. Okay, and you have here is going to be the bottom to the top, which is to the new curve. So in this case, you're gonna have to have two pictures. The first one will be, okay, number 1, okay, so and number 2, okay, so you have the double integral over the region number 1. So I'm gonna just draw a triangle. So for this one, and you have the smaller one. Okay, so this one is gonna be number 1. Okay, and you're gonna also have number 2. Okay, so this one is your number 1. So you have the bottom one, which is the line y equal to 0, and you have the top one, which is y equal to 3/4 x. okay, and you gonna have this guy going up, okay, so it's gonna be going up. So you see that it's gonna just write down y equal to 0 to y equal to 3/4 x. Okay, so that is gonna be our setup. The second one is gonna cover from 0 to 4 of your x. So it's gonna be 0 here and 4 here, and this guy will be your yellow guy. So you just put 0 to 4, 0 to 4 in this picture. Okay, so it's going to be that the first region. And you have the second one, f x, y, dy, dx. The second one will take care the second picture. The second picture will be just you have this guy and you have the lower one, which is the x-axis, and you have this circle, okay, and this guy will be your equation. However, we would need equation in terms of y. Okay, so you need equation in terms of y, and you see that this equation that we would have is going to be the top equation. Let me erase this guy a little bit. So we need the equation on top. Okay, so you need this equation for this curve. How could I make it clearer? Let's use some color. So you need this purple guy, okay? And this one, you see that this one you have x squared plus y squared, x squared equal to 25 minus y squared, and you solve for y, so you get y squared equal to 25 minus x squared, and you have y equal to square root 25 minus x squared with the plus or minus sign. Okay, so with the plus or minus sign, and you have here that y will be above the x-axis. When you have y above the x-axis, you have y positive. Okay, so you have y positive, so it's gonna be positive. Okay, so it's gonna be positive, so it's gonna be y equal to the positive 25 minus x squared. Okay, so it's going to be the positive square root. Okay, so it's going to have equation square root 25 minus x squared for this guy. And you have the x-axis, which is y equal to 0. And the picture for number 2, okay, so this one is number 2. The running turned out to be in the vertical way, so it's gonna run in this form. So it's gonna be y equal to 0, y equal to 0 to the top guy, which is y equal to square root 25 minus x squared. Okay, so that I would highlight with the red color. So this is gonna be this setup, and you have x lie between 4 to 5. So this one is 4, this one is 5. So it's gonna be 4 to 5, and this guy will be just 4 to 5. Okay, so it's gonna be this guy, and you would just sum them up. Okay, so you would just sum them up. So you basically sum these two up to give you the final answer for this double integral. Okay, so this guy will be equal to the sum of these two, okay, and it's gonna turn out to be the two pieces that we have to do them separately. Okay, so this one is a little bit difficult, so I chose to show you in this clip. The next one will be the question ask you to sketch the region. Okay, so you need y equal to x, y equal to negative x, and 2x plus y equal to 3. And we like to sketch the region, and we like to set up the double integral in two ways, dx, dy, and dy, dx. So what does it mean? It means that if you sketch this region, you would see, so it's gonna be, you have the region and you're gonna have y equal to x, which is this line. You have y equal to negative x, which is this line. Okay, so you have y equal to x, y equal to negative x. Let's just put y equal to x, y equal to negative x, and you have 2x plus y equal to 3. So we need like a 2 point. So you have x, y, and normally we would just use intercept. So we have x equal to 0, y equal to 3, and y equal to 0, x equal to 1.5. Okay, so it's gonna be 0, 3, 0, 3, 1, 2, 3, 1, 2, 3, and 0, 1.5. Okay, so I need something longer. I need something longer. Let me. Okay, so I need this guy a little bit longer, and you need to like kind of find the intersection point between these two curves in order to have it. However, I would just say that I have the thing that we're looking for. So just say that I need 1, 2, 3. So I need 1, 2, 3, and I need 1.5 somewhere here. Okay, so I will try to draw. It's too small. Let's choose. Okay, this one is better. 1, 2, 3. Okay, so you're gonna have 1.5 somewhere in the middle here, and you need 1 here. Okay, and I'm gonna try my best to draw the line. Okay, so let's use. Okay, so that is gonna be quite nice. So it's gonna be, let's do it again. So you have 3 here, you have 1.5, okay? And you see the intersection point, which is here and here, okay? So you have 2 intersection points, and you can guess from the scale. Okay, so basically you can guess from the scale that this one should be at 1 and at 3, right? And it's going to be at the origin. So you have 1 and you have 1, and you would think that this guy will be -3. Okay, how would I know them? Okay, how would I know them if I don't want to guess? It's going to be just you need to solve for intersection point for all of this curve. So this curve is 2y, not 2y, 2x plus y equal to 3, and you have y equal to -x. Okay, so you have y equal to -x. Okay, and you have y equal to x. Okay, and you have the intersection point, which is here. And you see that the region that we are having is here. Okay, so the region that we are having is here. Okay, so we gonna just try to like set up the double integral in two different ways, but we must first label the intersection point. Let me show you how I would just find the intersection point. You see the green equation, y equal to -x, and you have the blue equation, 2x plus y equal to 3. So you just have to put y equal to -x into this equation. So you see you have 2x, you have y equal to -x, so it's going to be minus x equal to 3. So you get x equal to 3, and you plug this back in. So you have y equal to -3. So the intersection point is at 3, -3. Okay, so that our intersection point for the green one and the blue one. And you also be able to find the intersection point between the red one and the blue one. 2x plus y equal to 3. So this guy you plug into this equation. So you have y equal to x. Okay, so let me just plug this one to y. So you have 2x plus x equal to 3. So you must have 3x equal to 3. And you just have x equal to 1. And you have y equal to 1 by plugging back this guy. Okay, so this one turned out to be the next intersection point 1, 1. Okay, so that we have here, you have 1, 1 and 3, -3. And you gonna find the, so this one is going to be the region R. Okay, so this one will be the region R. So you have the double integral of fxy dA. So you would set this thing up in two different ways. So it's going to be the double integral fxy dx dy. So the thing that you see is going to be you must have dx dy, and another way is going to be dA turn out to be dy dx that we're going to do next. For dx dy, you have x run first. When you are having x is running, so it's going to run horizontally. So you have seen that this one is going to be the red to the blue. Okay, so it's going to be the red to the blue. And you see the second one that is going to be the green to the blue. Okay, so this one is going to be two different picture. So it's going to be two regions in this case. So you need two double integral. So it's going to be this guy, and you're going to add by the double integral of xy dx dy. And the region that you see that the top part is going to be the red to the blue. So it's going to be the picture like this. So the red to the blue. Okay, so it's going to be the red to the blue. So it's going to be this guy, and you have the bottom. Okay, so that is going to be my picture, represent the first region, and the second region will be the green and the blue. And you have the bottom. Okay, so the equation that you have here, you're going to have this guy running in this direction, and the red one has equation x equal to y. Okay, so when you have running from left to right, you must have x in terms of y. So for this one, the second one, which is the blue one, will be you solve for x. So it's going to be x equal to 3 minus y over 2. Okay, so it's going to be x equal to 3 minus y over 2. Okay, and your x will cover from 0 to 1.5. Okay, so it's going to be 0 to 1.5. Okay, so this one will be put here 0 to 1.5, and this one is going to be x equal to y, and the top one will be x equal to 3 minus y over 2. Okay, so that will be the setup for this first integral. And the second one will be, you see that your picture will come from 0. Okay, so the picture will be from 0, and you see that this one will be, sorry, it's not 0 to 1. I didn't have that. It's gonna be 0 to the top part. Sorry. So this one is not 0 to 1.5. It's gonna be 0 to 1 instead. So it's gonna be 0 to 1. Okay, so from this picture. Okay, so the thing that you have seen is must be 0 to 1, and my one is pink. So yeah, okay, so it's going to be 0 to 1. I wrote it correctly because I take a look at this picture. For the next one, you see that it's going to be from the green one, which is x equal to negative y. And for the blue one, you have x equal to 3 minus y over 2. And you have this guy to this guy, this guy to this guy. So you have x equal to negative y, and x equal to 3y minus 2. Okay, and you will have to cover the bottom one, which is from here to here. So it's going to be 0 to negative 3. Okay, so it's going to be 0 to negative 3. So it's going to be negative 3 to 0 when you write down, because you need this direction. So it's going to be from the bottom to the top. Okay, so it's going to be like a positive direction in that case. So this one will be the setup for the double integral using dx dy. For the second one, you will need to set up using dy dx. So I'm gonna just have another one. So I'm gonna just make this guy a little bit smaller. Okay, so if I like to set up another way, so I'm gonna just have double integral of fxy dy dx. So for double integral of fxy dy dx, y gonna run first, so it's gonna be running vertically. So when you have this guy running vertically, the separation turn out to be at x equal to 1, that you're gonna have the first picture and the second picture. And you see that for the first picture, it's gonna be from the green to the red. And in the second picture, it's gonna be the green to the blue one. So for this one, the picture would be the green to the red. So you just have this picture. Okay, so you have y equal to x negative x, and you have y equal to x. Okay, and your x will cover from 0 up to 1, okay, horizontally. So this one is going to be 0 to 1. So we're gonna just put y equal to 0 to 1, and you're gonna have y equal to negative x down here and y equal to x up here. So this one will be the picture correspond to the first double integral, okay? And for the second picture, it's gonna be this picture, okay? So that you have this separation. So it's gonna be the green one to the blue one. So it's gonna be plus, okay? Yeah. It's gonna be plus the double integral of fxy dy dx. So for this one, it's gonna be the green one. So it's gonna be the green one to the blue one. Yeah, I have to think about this one a little bit. And the blue one on top. Okay, nice. So you have this picture, okay? And you see that the green one has equation y equal to negative x, and the blue one, you have to solve for y. So this guy y equal to 3 minus 2x, okay? So it's gonna be the top one, 3 minus 2x. And your x will cover from 1 up to 3. Okay, so it's going to be from 1 to 3 here. Okay, so it's going to be here for x equal to 3. Okay, so it's going to be that my x. So you see that you are running vertically. Okay, so you're gonna run vertically here first, here running vertically. So you're gonna have the green one to the blue one, which is y equal to 3 minus 2x, and you have y equal to negative x down here, and it's gonna be running from 1 to 3. Okay, and that's all. Okay, so this one is the setup that we have for this question. So you see that it's gonna be two setup. Okay, one will be dx dy, and another one will be dy dx. Okay, so this one is how we have this double integral in two different setup. Okay, so in the last example, you like to compute the volume of the solid above the xy plane under the surface. So this one will be your function fxy. Okay, so this one will be your function fxy. So you have the double integral. So the volume will be the double integral over S, okay, of your fxy is e to the negative x cubed plus 1 dA. Okay, so it's going to be this volume that we used to set up. And you see that this one is easy because you have y between constant. Okay, so this one is going to be, you have y between constant and x between curve. So for this one, we learned that this guy must be inside and this one must be outside. Okay, so it's gonna be, you have the double integral of e to the negative x cubed plus 1, and you have x inside, so it's going to be dx dy, and it's going to be root y to 2 and 0 to 4. Okay, so this one is easy to set up because you have like one variable turn out to be constant between two constant, and another one turn out to be curve. Okay, I should put as, okay, it's going to be between two constant and two curves. The difficult thing for this one turned out to be integration. So you see that for this one, it's impossible to integrate like we faced before. Okay, so this one is turned out to be impossible to integrate. Okay, so this guy turned out to be impossible to integrate. It's not going to be like the normal substitution that we used to do. Okay, so we must change the order. Okay, so we change the order. Okay, so we gonna just change the order. So the thing that we're gonna change the order is gonna be, we need to sketch the region. Okay, so what do you see? So you have x and y like this. So the thing that you see root y smaller than x, smaller than 2, and you have y between 0 to 4. So you would just sketch x equal to root y and x equal to 2, okay? X equal to root y is going to be y equal to x squared, okay? This one is going to be parabola. But like I mentioned before, so this one is square root, okay? So it's going to be parabola with x positive. Why do I know that x is positive? It's because square root positive, okay? No negative side here. If you have negative square root, it's going to be x negative instead. So for this one, you're gonna just draw me a parabola. So you have x positive, so it's gonna be parabola x positive, so it's gonna be parabola like this. Okay, so this one is y equal to x squared. And you also have x equal to 2. X equal to 2 is going to be vertical line. Okay, so it's going to be 2. Okay, so you see the picture y equal to x squared on that side and x equal to 2 on the other side. And you gonna have this guy running, okay, in this direction. And you have y gonna cover from 0 to 4. Okay, so it's gonna be 0 to 4. And your 4 is this vertex. Okay, so it's gonna be at this point. Okay, so that is going to be this picture. And the region S is where the region S turned out to be this region. Okay, so this one is going to be the region that we are working on. So we need to change the order. So from this guy, we must change this order to e to the negative x cubed plus 1 dy dx. Okay, and you're gonna have y running first. So it's gonna be running in this vertical direction. So you see it's gonna run from the bottom, which is y equal to 0, to the top curve, which is the blue curve, y equal to x squared. And you have x cover from 0 up to 2. Okay, so it's gonna be 0 up to 2. Okay, and that's it. Okay, so you see that it's kind of easy to change for this picture. And we're gonna compute this double integral. So we're gonna compute the inside first. So it's gonna be e to the negative x cubed plus 1 multiplied with y from y equal to 0 to y equal to x squared. Because what? Because you see that this guy will turn out to be constant. Okay, so this one is going to be constant. And when you integrate constant, you have constant multiple. Okay, so it's going to be integrate constant dy. So it's going to give you this one. And you're going to continue computing. So it's going to be x cubed plus 1. And you have x squared minus 0. Okay, and you're going to just have 0 to 2 dx. Okay. And so you're gonna just use the substitution. So you're gonna use the substitution by letting u equal to negative x cubed plus 1 du equal to negative 3x squared dx. So you have x squared dx equal to du over negative 3. Okay, and you have x equal to 0, u equal to minus 1, x equal to 2, you have u equal to minus 9. So this guy will be negative 1 to negative 9 of e to the u, and you have du over minus 3. Okay, so that will be my x squared dx. Let's use some color. I know. So for this one, it's gonna be x squared dx. So it's gonna be du over negative 3. Okay, and you have 0 change to negative 1, and you have x equal to 2 change to negative 9. Okay, and you gonna have u equal to this guy, everything. So this one is kind of bigger substitution as than we used to see. And this one is going to be just easy to integrate. So it's going to be just negative 1/3 e to the u from negative 1 to negative 9. So it's going to be negative 1/3 e to the negative 9 minus e to the negative 1. So this guy will be 1/9 e to the negative 1 e to the negative 9. Okay, that's all. Yeah. And this one will give you the final answer. I would suggest you to do exercise 15.3 in order to gain the experience in like changing the order, sketching the region, and you're gonna have to be able to compute the double integral by changing the order. Okay, so this one will be just the thing that happened for your final exam. Okay, and this one is going to be all of the thing that we have for this script. It's going to be kind of the question can ask you to set up into different way. The setup, the question can ask you to change the order from dy dx to dx dy, and the question can ask you to evaluate the double integral in like by just not give you the one that you be able to integrate right away, but you need to change the order so you be able to integrate it out. Okay, so that's all for this script.